Hi again, Physics 20. I'm going to make a video now of a 2D projectile question. It's number 3 from the 2D projectiles assignment. Okay, so we're saying we've got a projectile fired 120 meters per second, 40 degrees from the ground. So I'm going to draw that vector right now. And as always, we are going to find out the x and y components of our vector. Okay, let me start by finding x. That's going to be 120 cosine 40. Okay, I get 91.9 meters per second. All right, and just a reminder that we only use to find the horizontal distance. Question 1's asking for time to get to the maximum height. This isn't going to matter at all until we find that horizontal distance. So quickly get Vy here. I get 77.1. Okay, so I just want to remind you that this projectile reaches the same height as a projectile thrown with this speed directly up. Okay, so our 120 meters per second at an angle will follow a parabolic path like this. It'll reach some kind of maximum height. So this is 120 meters per second at first. Okay, if we just threw one straight up at 77.1, we'd go up, and of course come straight back down. Okay, the horizontal speed makes it go horizontally. It does not make it stay in the air any longer. It does not make it go any higher. So let's set up our kinematics now. We're looking for the time it takes to reach the maximum height. We know Vi. Remember, you always use the vertical. All right, the vertical speed, 77.1 meters per second up. We know the acceleration is 9.81 meters per second down. All right, at the maximum height, we know that Vf is equal to 0. We are looking for a time here. Okay. We are going to be able to figure this out just with the definition of acceleration here. All right, we've done this a few times. I'll set it up, but I think I'll skip a step near the end. So the acceleration is 9.81 down. Vf is 0. We're subtracting 77.1 up. And we're looking for the time. 9.81 down. This becomes negative 77.1 up, which is down. If we shuffle this around a bit, we're just going to get that the time will be 77.1 divided by 9.81. So let me just squeeze it into the corner there. Okay, I get an answer 7.86 seconds. Let's flip the page. Now we want to find the actual maximum height reached. We're going to have all kinds of freedom in how we want to do this. We can still say Vi is 77.1. We know Vf is 0. We now know the time. And of course we know the acceleration. When you know 4 variables and you're looking for a 5th, it's your choice. You choose whatever formula you want. I've made the suggestion that anytime you can use a 0 is very helpful. So I'm going to say, let's do this. Because Vf is 0 at the maximum height, so we can get rid of that right away. So A is 9.81 down. Our time, 7.86. Please remember to square it in these formulas. I'm still seeing people messing that up, which is no fun. Because there's nothing worse than doing everything right except getting the answer wrong because of a slip up with your math. Okay, so I'm just going to quickly do this. Okay, I get a maximum height of 303 meters, which is quite high. And I'm just going to point out, this thing's moving 77.1 meters per second up, that's incredibly fast. Okay, we're talking over 200 kilometers per hour. So, total time in air. Well, that's a weird one to have after B. This projectile is shot from the ground. We have no reason to assume it lands anywhere other than the ground. And we've discussed this. If it returns to its original height, the time to go up is equal to the time to go down. Okay, there's some nice symmetry there. So the total time, we just have to take our answer from part A and multiply by 2. So that's really nice. Let's call that 15.7 seconds. Okay, horizontal distance traveled. This is always a nice way to end because it's such a simple calculation. We just take the horizontal speed. That was our 91.9. This is not affected by gravity. Our projectile is going to be moving horizontally at the same speed until it hits the ground. We know it hits the ground after 15.7 seconds. So we just need to multiply those together. Okay, I get about 1,445 meters. Okay, there will be a 2D projectile question on the test coming up. There always is. I hope this helps. Good luck.